Hello, this is Kate, and welcome to my math final project. So I'm going to be touching on 3 problems, one from 6-2, one from 8-2, and one from 10-7. So our first question comes from Unit 6-2, and to understand it, we need to know property 6.3. And property 6.3 says that if a quadrilateral is a parallelogram, then its opposite sides are congruent. So, bearing property 6.3 in mind, we're going to solve this problem from 6-2. Alright, so we are given this quadrilateral, LMNO, and we are told that LM is equal to 5A, MO is equal to B plus 8, ON is equal to 2A plus 9, and NL is equal to 4B minus 4. And the instructions say, if LMNO is a parallelogram, find A and B. So remember, property 6.3 says that if a quadrilateral, which is this shape, is a parallelogram, then its opposite sides are congruent. So we know that this is a parallelogram, we can infer, and so we are going to set these two numbers up because they're on the opposite sides, and we're going to set them up to equal each other because remember, the opposite sides will be congruent, meaning they will be equal. So, we can set up 5A is equal to 2A plus 9. So do some quick solving. Subtract 2A. Given 3A is equal to 9 divided by 3. We know that A is equal to 3. So we found A, but now we need to find B. So we write that down so we don't forget. All right, so we're going to do the same thing, but with these other measures. So we're going to set it up the same way. 4b minus 4 is equal to b plus 8, and then solve that. So subtract b. 3b minus 4 is equal to 8. Add 4. We get 3b is equal to 12, so divide by 3, and we get b is equal to 4. So we know that A is equal to 3 and B is equal to 4, so we have solved the problem. Alright, so our next problem comes from section 8.2. And we're given the instructions. Determine whether or not this set of measures can be the measures of the sides of a triangle. What kind, meaning what kind of triangle. So we are given the 3 numbers 24, 18, and 30. So let's see what we can do with that. So we then learned about these 3 equations. So if these measures can fit into this first one, a squared plus b squared is equal to c squared, we can classify the measures as belonging to a right triangle. Now if we go down to the second one where it says a squared plus b squared is greater than c squared, we can then classify the measures as belonging to an acute triangle. And then the last one, a squared plus b squared is less than c squared, we can classify the measures as belonging to an obtuse triangle. And remember, we were given the measures 28 or 24, 18, and 30. So let's see if it fits any of these. So we have a squared plus b squared is equal to c squared. And we don't necessarily know that it's going to equal it. It's just the basic equation that we need to plug the numbers into. So we can do 24 squared, because that was our first value, plus 18 squared, that was our second value, is equal to 30 squared. And now we need to square all of the numbers. So 24 squared is 576. 18 squared is 324. And 30 squared is 900. So we add up 576 and 324 and we get 900. So we know 900 is equal to 900. And remember, a squared plus b squared equals c squared is the equation of a right triangle. And we know that 900 is equal to 900, so these measures belong to a right triangle. So the last question comes from 10.7, and here we learn another rule. We learn theorem 10.15. All right, and theorem 10.15 says, if two chords intersect in a circle, the products of the lengths of the chord segments are equal. So keep that in mind, and I'm going to show you our problem. So we're given a circle to split right down the middle and then towards the lower half, and we are given these measures. And the instructions say to find x. So, as we learned a few seconds ago, if two chords intersect in a circle, so these two chords intersect right here, then the products of the lengths of the chord segments are equal. So the products, meaning we multiply them. So 12 times x, because remember that these intersect, and the products of the lengths of the chord segments, so this length and this length multiplied, are equal. So it will equal this length and this length multiplied, if that makes sense. So we'll set up our problem. So we have 12x is equal to 6 times 6. So that's pretty simple. We know 6 times 6 is equal to 36. And we still have 12x. Then we can multiply by, or divide by 12 to get x alone. And we get x is equal to 3. So we know that this value is 3. So those are all of our problems, but I'm gonna kind of recap what we've talked about. So we touched on property 6.3. And remember that says, if a quadrilateral is a parallelogram, then its opposite sides are congruent. So if we're given a parallelogram right here, and we have x and y, we know that x is equal to y because they are opposite sides and they are congruent, meaning they are equal. We also touched on a topic in 8.2 on how to classify a triangle by when you're given the measures. So we talked about if it fits a squared plus b squared is equal to c squared, it belongs to a right triangle. But if a squared plus b squared is greater than c squared, we know that it belongs to an acute triangle. And similarly, if a squared plus b squared is less than c squared, we know that these measures belong to an obtuse triangle. And theorem 10.15 says, if two chords intersect in a circle, then the products of the lengths of the chord segment are equal. So if we're given a circle and we see that these intersect right here, this measure, whatever it is, we'll say it's x, is, if we multiply it by whatever measure, if you continue down the line, whatever measures on the other half, we'll say that's y, and that these are z and w, we can guess that x times y will be equal to whatever z times w is. So that has been my math final assessment. And that's all I have for you, and I hope that you have enjoyed it, and I will see you all when we return to school next year.